Alright folks, so in this video I'm going to cover something related to the analysis of variance, and that is the sources of variance. So as we know, the f-test is the ratio between the mean square between and mean square within. Now, in order to figure out how to calculate the f-test, we have to understand SSB, which is the sum of squares between and sum of squares within. So we're going to spend some time talking about this, where sum of squares between and within are coming from. Now, k minus 1 is easy because k minus 1 is the number of groups. So number of groups minus 1. So if you have 3 groups, k minus 1 will be 2. For degrees of freedom between. N minus k is easy too, because the only thing you have to know is the n and the number of groups. So if I have a sample size comprised of 10 individual, and I know that the number of groups is 3, so the degrees of freedom here in this case will be 7. So these are easy to figure out. And then these k minus 1 will be the denominator for MSB. MSB again is the denominator of the f test or f ratio, and n minus k is the denominator of MS within. So this is given. This is easy. Again, the idea is the question is SSB and SSW. Where are these values coming from? So this is the main purpose of this video here. Okay, so let's go ahead and move forward here and try to figure out where SSB and SS within are coming from. So basically, SS stands for sum of square deviations. And we kind of did that when we cover variance. Remember, in order to calculate the variance, we did take the sum of square deviations divided by n. Square deviations, what do you mean by square deviations? Well, we took every single Roy score and subtracted that score from the mean, and then squared it, and then divided by n. So the sum of square deviations from the mean. So we did that when we calculate the variance. So with the ANOVA of variances, it's pretty much the same. Again, we apply the same idea of sum of squares here from the mean, but in this case it's going to be sum of squares b and sum of squares within. So let's talk more about that. So now you know what SS stands for, you know where it's coming from. Now let's see how I would eventually get SSB and SSW. Okay, so let's move on here. Now, SSB has to do with between group variation. And again, in order to get MSB, I need to take the ratio of SSB and k minus 1. We saw that before. But again, let's focus on SSB. What's SSB is coming from? Where the value of SSB is coming from. So that is the deviation or variance, because this is analysis of variance. So deviation variance of group means. Let's say I have 3 groups. So each group will have a particular mean, correct? So this is the SSB in this case would be the deviation of group means from the grand mean. What is the grand mean? Well, the grand mean, let's move forward here, then I'll come back. I wish I had it before here. What is the grand mean? The grand mean is the sum of all scores, all Roy scores divided by n. That's the grand mean. Combine with all 3 groups in this case, all 3 groups combined. So if you take every single Roy score on your sample, like say 3 groups, and sum those scores and divided by n, you're gonna get the grand mean, x bar GM in this case here, or x bar grand is the same thing. Okay, so the SSB is the deviation or variance of group means. Again, say if I have 3 groups, I have 3 means. So the deviation of group means instead of Roy scores. When we calculate the variance, we use Roy scores. In this case here, we are taking SS, or sum of squares, of between variance. So, or between means, or between group means. So deviation of group means instead of Roy scores from the grand mean, and that is SSB basically. So that will be the numerator of the F ratio, MSB, right there. Okay, so now you know where SSB is coming from. So let's go to the SSW. Well, as you probably guess, this is the within group variation, SSW, and you divide that by n minus k, and that will be, and you get then MS, mean square, within, which is the denominator for the F ratio. Now, where the SSW is coming from? Well, each individual score in your data set, okay, deviates from the mean of its own group. So let's consider now each group separately, okay? So let's say group 1. Each individual score in group 1 deviates from the mean of its own group, of group 1, okay? And the same thing for group 2, and the same thing for group 3. That's why it's called within group variation. Okay, so the deviation of the individual scores from the mean of the group, and that is the denominator of the F ratio. Okay, so now you know where SSB is coming from. Now you know where SS within is coming from. And then the total variance. The total variance is not part of the F ratio, even though the total variance would be the deviation of individual scores from the grand mean. So the deviation of every single score in your data set, regardless of group, from the grand mean. This is not part of the F ratio. So this is left out. So the only thing that's part of the F ratio when calculating the analysis of variance is SS between, which is the deviation of group means from the grand mean. This is the grand mean, and we look at the within group variation. So sum of squares within group variation. Each individual score deviates from the mean of its own group. Okay, so that's the SSW. Let's move on here. This is not that important for us. So with that, we finalized this short video here. So like we did with when we calculate the variance, we mentioned that before. We take the sum of square deviations from the mean. Each Roy score deviated or subtracted from the mean, and we square those deviations. And we got the variance for a particular sample. So X is Roy score, and this symbol right here is X bar. It's the mean for the sample. ANOVA is similar, as we mentioned before, so we're concluding here. With ANOVA, we look at the sum of squares, or SS, but then we look at between and within. So in a way, we use SS with between and within. So for SS between, we look at the sum of square deviations, and the deviations are basically the group mean minus the grand mean. Group means, the group means, because we have more than 2 means, so the group means minus the grand mean, that number squared. So that's the sum of squared between. And again, the sum squared within would be the sum of square deviations from the mean. What mean? The group mean. So we take every single raw score within each group, and we subtract that value, that score, from its mean, the mean for the group. And again, the SST, which is the sum of squared total, is not part of the F ratio. You could calculate, but it's not part of the F ratio. Okay, so to finalize here, ANOVA, when we calculate ANOVA, basically what we do is we take the size of the sum of squares between and compare with the size of the sum of squares within. That's the F ANOVA right there. Okay. If you have further questions, just send me an email, or actually even better, post your questions to our forum, forum on Canvas, and I'll be glad to answer your questions. I'll catch you later.